All right, here we are for the second half of section 11.4 on derivatives. The target today says I can find and apply derivatives of functions. Notice we're going to do that application piece today. The purpose says you will understand and explore derivatives through online activities so that you will have the prior knowledge necessary to be successful in calculus. So the goal of this chapter is really preparing you for calculus next year. Your work on derivatives looked great. The ones that I've graded so far from period 1, I've graded all of your work from 11.4 yesterday, and it looked really great. So I expect to see the same from the other classes, and yeah, keep up the good work. So our reminder, we're actually going over this in the live Zoom. So, what is a derivative? A derivative is when we take the limit of the difference quotient and it gives us the slope of the tangent line. Remember, slope is rate of change is what slope is. So we're looking at the rate of change of a function when we look at derivatives. So we're going to hop right into example 6 on your handout. And here's what it says. Use the function f of x equals x cubed, which describes the volume of a cube, to find each of the following. So we're going to answer 2 questions. Part A, find the average rate of change of the volume with respect to x as x changes from 4 inches to 4.1 inches and from 4 inches to 4.01 inches. So, so this one is kind of interesting, I think, because it shows you what the formula really means. So if I do f of x plus h minus f of x over, there's that line again, over h. Let me show you how those words represent what's actually happening in this problem. So it says, find the average rate of change of the volume first when it changes from 4 to 4.1 inches. We're actually just going to do this one. So here's what that says. X, right, is the length of the side of the cube. So picture a cube, right? Here's our cube. The side is x, so all sides are x. So it wants to know at what rate is the volume changing as the side changes that little bit, right? Think about applications where we might care about the volume of a box shipping. Amazon might care about the volume of their boxes. So here's what this says. F of x plus h. X is your starting point. H is the change. Okay, so x here is your starting point, the 4 inches. It's changing from 4 to 4.1 inches. So 4.1 is your x plus h, which means your h is the 0.1. So 0.1, h represents the change in. When we take the limit as h goes to 0, we're saying as the change gets down to like instantaneous, it gets right on top of each other. Here we have a specific h. What happens as it changes from 4 to 4.1? So 0.1 is our change, our ending amount, our starting amount. We're really finding slope here is exactly what we're finding, the rate of change. So we're doing 4.1 cubed minus 4 cubed over the 0.1. We plug that in our calculator and we get 49.21. Now the units on this are inches cubed. Okay, we're talking about a cube, right? This is cubed, this is cubed. So inches cubed over, what was the unit on this 0.1? The difference there was just inches. So how does this make sense with the definition of the derivative? The volume is changing by 49.21 cubic inches per inch that it changes. But what's kind of interesting is that it's only true at that very point. Okay? All right. So we have that idea of, what does this represent? With those cubic inches, the volume is changing over the inches. Thinking about, the units in our actual fraction. So I like that problem just because you can see really like what are the quantities we're dealing with. So then part B talks about the instantaneous rate of change of the volume with respect to x at the moment when x is 4 inches. So instantaneous rate of change, when we see that, that is the derivative. Okay? As soon as we see derivative, we know our formula, right? The limit as h goes to 0 of f of x plus h minus f of x over h. Okay, that definition we just got to talk about up here, you know, a little more concretely. What does h mean? But now we're going back to the basics of derivatives. So remember that our function f of x is x cubed. So the limit as h goes to 0 of x plus h cubed is what happens when I plug that in, right? Minus x cubed is the original function all over h. Okay, so I'm taking the limit as h goes to 0 of x plus h times x plus h squared, which we've done a bunch. X squared plus 2xh plus h squared. Subtracting my x cubed, I'm going to put divided by h to save a little space. Now I'm going to distribute in. I get x cubed plus 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed. Whew! And then I subtract x cubed, and it's all over h. Now, if that got confusing to you at all, here's what I was doing. I was giving out the x to each of these terms, right? And then I was giving out the h to each of these terms. And here I think it's just being careful. I saw really good, careful work in the submissions that I saw. And that's what you need to, you know, keep it up. So what happens now? My x cubes cancel. Does anything else cancel? No. So I have, I can combine some like terms. I have a 2x squared h and a 1x squared h. So that is 3x squared h's. I have an xh squared, a 2xh squared. So that is 3xh squares. And then I have my plus h cubed. I divide that all by h, meaning I can take an h out of each one. 3x squared plus 3xh plus h squared. All right, now what happens when I can finally do the limit as h goes to 0 of that quantity? I plug the zeros in. For h, 3x squared plus 3x times 0 plus 0 squared is 3x squared. So 3x squared is my derivative. F prime of x is 3x squared. And what does the derivative do? It gives me the rate of change at any point. What point am I talking about here? I am talking about the point exactly when x is 4. So I plug in 4. And I get 48. Now I have to think about the units there again, right? The units are my cubic inches per inch. When you think about the units, you're thinking about this fraction here, right? If these quantities are in inches, but they're cubed, that's cubic inches. H is the change in, so that's just going to be in inches. So at the exact moment when the side is 4 inches, my volume is changing at a rate of 48 cubic inches per inch. All right. Real quick, want to show you a fancy shortcut. You can't use it now, but you'll talk about it next year. If I have my function, f of x is x cubed. Okay. To get f prime of x in the most simple version, we take this, drop it down out front, and we subtract 1. I get a 3 out front. 3 minus 1 is 2. There is your 3x cubed that we got this way. Now, I show you that just because I want you to know there are faster ways, but there are also much more complex functions that you'll get into in calculus. And in calculus, you do have to be able to do this way. Remember I said on the AP Calc exam. So this is what you have to show me. This is a nice way to check your work. If I just give you a nice polynomial, that's a quick way to check your work, but you must show this whole thing to get credit. All right, jumping into number 7. Okay, number 7, we have another volume problem. The function f of x equals 6 pi x squared describes the volume of a right cylinder with a height of 6 feet and a radius of x feet. If the radius is changing, find the instantaneous rate of change of volume with respect to the radius when the radius is 8 feet. So again, when we see instantaneous rate of change, we know we're being asked to find the derivative. All right, so we have our function f of x, which is 6 pi x squared. We're going to do f prime of x, the derivative, which is the limit as h goes to 0 of f of x plus h minus f of x over h. So the limit as h goes to 0 of 6 pi times x plus h quantity squared minus 6 pi x squared all over h. What do I get? I have to FOIL out the x plus h squared, so I have 6 pi times x squared plus 2xh plus h squared. Hopefully you're starting to get, comfortable and familiar with that. Minus 6 pi x squared all over h. So I get 6 pi x squared plus 12 pi xh plus 6 pi h squared minus 6 pi x squared all over h. So here I look for what cancels. My 6 pi x squared is canceling. I have 12 pi xh plus 6 pi h squared, and that's all over h. And h cancels out, 12 pi x plus 6 pi h. I can now take the limit of that as h goes to 0, and I get 12 pi x plus 6 pi times 0. So the only thing that is left for my derivative is 12 pi x. So there is my derivative. I want to know what is the instantaneous rate of change when the radius is 8 feet. So I plug in 8. And I get 96 pi. Now thinking about those units, the radius is in feet. So I am cubic feet per foot. So at the moment when the radius hits 8 feet, our volume is changing by 96 pi cubic feet per foot. All right, I'm going to pick up with the last 2 examples in the next video.